Okay, great. So welcome everybody. My name is Josh Brothheim. Let me go ahead and turn on my video just to show there's a live person. Hey everybody. And I'm going to be leading today's session on, as the title says, and hopefully you're anticipating, Root Cause Explorer. So we're going to look specifically at multi-cloud root cause analysis with Sumo Logic. For today's session, we're going to be together for the next hour or so. It's going to be a fun hour. I hope you enjoy it. And so we're going to be doing some slides. We're going to be doing some labs, a little interactive as well. And if there's any questions throughout today's session, go ahead and put them in the Q&A or the chat. I have my peers, John and Approve, who are joining us and can help assist answering questions. And if there's any, please ask them. So away we go. So yeah, let's go. I'm going to turn off my video just to save a little bandwidth here. And you should see my screen. Yep, okay, we're good to go. So our agenda for today, pretty straightforward agenda, going to keep it kind of simple. We're going to do an introduction, which is me talking right now. We're going to talk about observability within Sumo Logic. I think it's important to kind of set the groundwork for the discussion today. So we'll do a little bit there. And then of course, we're going to focus on Root Cause Explorer, the real kind of the reason we're here today, and take a look at it and see what makes it tick, how it works. For those of you who don't know, I guess I should give a brief introduction to Root Cause Explorer. Of course, we're going to go much more detailed, but just at a high level, what it does is it helps on-call staff, DevOps, infrastructure engineers accelerate troubleshooting and root cause isolation for their incidences in their apps and microservices that are running on AWS, public cloud hosts, or Kubernetes. The Root Cause Explorer is going to help us correlate unusual spikes that are referred to as EOIs, or events of interest. And like I said, we'll look at those, of course, in much more detail shortly. Wanted to give an overview of Sumo Logic. Some of you may be familiar with us, some of you may not. Either is fine, of course, no expectations there, but did want to explain a little bit about where we sit and how we can assist. So digital transformation requires continuous intelligence, and businesses are leveraging a new category of software called continuous intelligence, which is real-time analytics and insights from a single cloud-native platform across multiple use cases to speed decision-making and drive world-class customers. So using our analytics across your operations, security, business, and global intelligence data provides you that continuous awareness to impact your results. So up on the top of the screen here, we have a couple different kind of examples or scenarios. Operational intelligence. Are your systems up and running? What is your MTTI or MTTR, those mean time to investigate, to identify and to resolve, which are really more and more critical every day. Other system health concerns can be assisted with Sumo Logic. Security intelligence is certainly a big use case of ours. Who is using root access? Is a person logging in from multiple locations simultaneously? Has your SIM picked up any actionable items? From a business intelligence standpoint, what pages are people frequently viewing on your website? What are they ordering? If you ran a marketing campaign, was it successful? Things like that. And then global intelligence. How are you doing, or how's your company doing compared to other companies, and observing your data on a worldwide level. Using your data-driven intelligence to use your data-driven intelligence to extract real-time insights and business values from massive volumes of machine data generated in the form of logs, metrics, events, metadata, traces, and other telemetry. These come from your apps, microservices, cloud systems, and infrastructure, SaaS, software as a service, mobile devices, and third-party system feeds, as you're seeing in this middle section where it says your data. We have built-in apps that provide you immediate functionality and will probably exceed 85% of your immediate query and analytic needs. If you're not familiar with our apps, they're a really great starting place for you. We won't really look at them today, but certainly highly encourage you to check them out. Let's see, what else about that kind of level? Our stack also includes support for, as I mentioned, SaaS, software as a service, and can integrate with third-party apps like Slack, webhooks, utilizing webhooks, ServiceNow, just to name a few. Finally, a couple more things here. Our analytics features multi-latency, where information is very secure. We advanced analytics and machine learning in our application. For example, you can very easily plot your data on a Mapbox plot and use machine learning to identify new security threats. And we cover that in some of our training classes. Because we are in the cloud, which is certainly an important thing, we're elastic and can scale the environment based on demand. We support APIs so that companies can incorporate Sumo Logic into other products, and we put the security of our customers first. As you see on the right-hand side of the screen here, Sumo Logic adheres to the host of industry standards and goes through attestation every year as appropriate. Current security certifications, PCI, SOC 2, HIPAA, and we got our FedRAMP just a few months ago, which was a big milestone for us. Your people, it's important to figure out or understand how your people fit into this. And really what we want to show here is you can achieve continuous collaboration across DevOps, engineering, IT, customer success, etc., with insights across multiple user cases from a single source of truth to facilitate collaborative thinking and speed decision-making. So like I said, just sort of felt it was important to give you a little bit of overview of Sumo Logic. If you're not familiar, if you are, great, hopefully you know and love us, but that's a little background. And now I wanted to talk about, kind of skip that real fast, but wanted to talk about end-to-end observability within Sumo Logic. Also, just to kind of level set, make sure we're all on the same page. Is about telling you the state of a system by looking at parts that have been configured to be monitored. If a part of the system isn't monitored, then we have no idea what's happening there. And knowing something is wrong is quite important. Observability, as I mentioned, goes beyond monitoring. So bringing those logs, those metrics, traces even, to give us a broader view and a deeper concept of what's going on. Okay, now this next slide here, come on, starting to discuss observability and the layers that occur within it. Observability requires more data and richer analytics as you go from an alert to a problem resolution. And so what we're trying to show here is at the top level, and we're trying to use a little iceberg, we are using an iceberg image here. At the top of the iceberg, if you will, or the image, is 20% of your data. And that's going to be used to identify what? Helpful for monitoring, looking at logs, metrics, and traces. As we go deeper, though, we start to see that more data is going to be utilized to get more involved into the troubleshooting. So it's important that this observability solution, whatever solution it is able to handle large-scale data sets. While monitoring and diagnosing requires working with some amount of data, it's the troubleshooting phase where the observability system should be able to handle unlimited amounts of data from log, metrics, and traces. And this is a challenge for many observable solutions that don't have a high-end or a highly scalable solution. Built on a cloud-native architecture, once again, Sumo Logic enables you to ingest and store any amount of data in that highly elastic and flexible way. And then secondly, the observable solution also needs to have a very scalable analytics engine. Observability requires you to analyze lots of data to machine learning and other initiative search-driven analytic capabilities. As a large-scale machine data analytics platform, Sumo Logic provides that out-of-the-box capabilities to support the ingestion and analytics of any amount of data. So important point there. And should have included that in the last shot. So as I was describing, more data is needed as we go deeper for more sophisticated analytics. One aspect to achieve the high-end end-to-end reliability is that unified observability platform. So what does that mean? Well, starting on the left-hand side here, what it means is it's required to get all bits of data telemetry to perform the tasks that teams who are in charge of reliability, DevOps, etc., DevSecOps as well, from each and every layer that affects the application. This data could be coming from your hosts, servers, application components like database, security, microservice infrastructure, cloud infrastructure, all these different environments that we're showing on the left-hand side of the screen. And as I mentioned a moment ago, it's required to have all relevant data, such as those metrics, metadata logs, and traces in Sumo Logic's platform for visibility. And so this allows you to monitor alerts, giving you the what happened information. We can diagnose using trace spans to figure out where it's coming from. And step 3, which is really where we're going to be focusing today, is the troubleshooting, using root cause analysis, as well as some other aspects to look at our relevant data and see how it fits into that end-to-end observability. So this slide, I thought it was important to identify use cases and teams. These should look familiar to you, hopefully. Hopefully you fit into one of these. And if not, of course, actually, I take that back. If you fit into one of these, great. If you don't, of course, Sumo Logic can still assist. But I wanted to talk about 3 kind of quick use cases or scenarios. And the SRE and DevOps team, those people that are responsible for monitoring the health of applications, they need observability so they can quickly monitor, diagnose, and troubleshoot those application health issues. Observability is also going to help the software engineer on the team, or multiples on the team, depending on how many you have, by providing visibility into the software pipeline. By collecting information about the software pipeline and identifying issues with the software delivery process, teams can improve the quality as well as the delivery of their application. And then observability also helps security teams ensure the security posture of their applications. What's unique about Sumo Logic observability solution is that it addresses the needs of all these teams and personas into one integrated platform. Just another visual, oh, and I'm sorry, I should have preloaded this guy here. So that DevSecOps that I just alluded to as well. And then this slide here wants to show, again, the monitor, diagnosing, and troubleshooting, kind of drilling that in. I know it's getting repetitive, but wanted to make sure we're clear on that. And we're going to be focusing once again on that troubleshooting step and primarily on that root cause for today. One last slide version of this similar content, but just in a different format. Is this slide here. So what this slide is mapping are the capabilities from that previous slide to that familiar 3-step observability workflow of monitoring, diagnosing, troubleshooting. And you'll notice that RCE, or Root Cause Explorer, is mapped to the troubleshooting phase, specifically right here in the red, pink, or fuchsia box. Finally, a quote that I find kind of a cute quote, but what we see is complexity is exploding, and as we deliver more functionality faster at the speed at which we need to troubleshoot and diagnose, applications need to keep up. And so this quote is kind of alluding to the fact that utilizing microservices is kind of like a murder mystery. So using RCE, as we'll see shortly, we're going to be able to tell that it was Professor Plum using the wrench in the observatory. So we're going to be able to see that in our data, which is really kind of cool. Or I guess I think it's cool. I don't know how cool data is, but for those of you that enjoy it, it is kind of cool. All right, so now let's start talking about really the subject at hand today, which is finding and solving and preventing failures using Root Cause Explorer. In this workshop, we're going to use Root Cause Explorer to accelerate troubleshooting and pinpoint the root cause for a few scenarios. A couple of those scenarios I'm going to do, we'll do 1 or 2 together as well. So you'll, like I said, you'll get that hands-on experience, which is always fun for everybody. But before we get too deep into looking at Root Cause Explorer, still have a little more to cover on the background. I think it's important to discuss the troubleshooting concepts that Root Cause Explorer embodies. Root Cause Explorer is built to enable 6 concepts that accelerate troubleshooting and issue resolution. And these concepts should be familiar to on-call staff, DevOps, and infrastructure engineers. These aren't, while we're using these concepts, we of course didn't come up with them. As you know, troubleshooting is cumbersome. That's probably part of the reason you're here today, is to see how it can be less cumbersome. And troubleshooting a production incident can be quite hard. Precious time is lost during an incident because on-call staff have to piece together logs, metrics, and trace data at the application infrastructure levels. They may use different tools and ad hoc queries to find the insights they need, and then analyze how services and infrastructure relate to each other before they can assess root cause and plan a recovery. In some, achieving those service level objectives can be hard, but fortunately there's a better way. With Root Cause Explorer, you can cut down troubleshooting time from 20 to 30 minutes to just a few minutes per incident and accelerate recovery. And we do this by automating, as just described, those 6 troubleshooting strategies that on-call users may be familiar with. And if you're not, you'll learn them. So let's start to go through them. Concept 1. There we go. Concept 1. As it says, spikes are the first symptom of an incident. Imagine you're managing a high-traffic e-commerce application. A spike in a crucial indicator, such as a payment service error, might be the first sign of trouble. And hopefully you agree that bigger spikes in crucial indicators imply bigger issues. So spikes can show us something is not quite right. In a complex system, the component or service that breaks first is the probable cause. Sequencing spikes over calendar time is an essential strategy for root cause analysis. And to continue with that idea, wanted to introduce the idea of events of interest. I think I mentioned them just briefly, but wanted to discuss them because we're going to be utilizing them in Root Cause Explorer. Anomaly detection, hard to say, is used in Root Cause Explorer and relies on entities that have sufficient history to create baselines of normal behavior. So how do you calculate baselines for short-lived entities such as Kubernetes? Kubernetes entities in the control plane and nodes, deployments, and stateful sets are long-lived, so there's not really a problem computing baselines for them. But pods and containers are short-lived, as they are created and destroyed by Kubernetes in response to workload requirements. The average container or pod lasts for less than a day. It's part of that ephemeral nature. And so Root Cause Explorer has a way to kind of handle those short-lived time series. Root Cause Explorer itself requires at least 2 days worth of history to construct baselines. So how do we do that if you need 2 days worth of history and pods last for 1 day? The trick here is we use aggregation of time series data for the pods and containers to the parent deployment or stateful set entity that are long-lived, and then compute baselines and drifts on the aggregate time series. And this is an important key differentiator for Sumo Logic. All right, now if we get back to our concepts here, little tangent on the concepts, but I think it was important to understand those EOIs, and when we see them in application will make more sense. Concept number 3 is context and correlation. So suppose this e-commerce app, this mythical e-commerce app we're using right now, relies on ELBs, EC2 instances, and maybe even RDS. Even in this basic example that we're starting to see here, when you start troubleshooting, it's important to know when an incident happened, which in this case, which AWS account and regions the incident happened in, and which application and microservices were affected. So we want to know all those things, when it happened, which things did it affect, and which applications were affected as well. In this example here, on the right-hand side of the screen, we see spikes in errors and other metrics that are correlated in a short time window from July 22nd. And so assembling such context and correlation automatically is a key strategy for root cause analytics. A couple more concepts here, and then we'll get to the good stuff. Continuing in our example, suppose this e-commerce app relies on ELBs, which front the payment service, which itself runs on a Kubernetes cluster. The payment service depends on the account services, which talks to the RDS database. Knowing these connections will help you correlate, for example, error spikes from the ELB to error spikes in the payment service, to CPU spikes in EC2 instances, which are themselves caused by throttled database requests. And in other words, correlations or connections help associate cause. Sorry, just had a problem there. Okay, I think I still have you guys. And in other words, connections help associate cause and effect in spikes observed at various levels in an application or infrastructure stack. All right. And if there's any questions about these, feel free to throw them in the chat. But a few more on the concepts here. Depending on data, what data is available, connections can be inferred from many sources, such as the ones listed here. AWS tags can be used to identify the application or service given an EC2 or RDS instance is serving. AWS X-ray, when used, can provide service-to-service linkages especially for services based on AWS Lambda, AWS configuration data, and Kubernetes metrics provide parent-child relationships in those environments. The Sumo Logic Service Map provides service-to-service connection information. Root Cause Explorer leverages all these approaches based on what is available. Concept number 5 is the real root cause. In our experience, incidences and outages are caused by one or more of these factors: unplanned load, bottlenecks, software defects, and/or configuration changes. So in this example here, one might conclude that throttling of database requests, was indeed the root cause that cascaded into EC2 CPU spikes and errors at the payment service and ELB levels. But that is merely the first level of root cause. You still have to explain what caused the RDS instance to get into a state where it's been throttled. In this example, an engineer may have changed the provision IOPS setting on the RDS table to save AWS cost. But that could have unintended consequences, as we start to see on the slide. And we'll go through an example like this, more thorough example in app in just a few moments. So getting there. A couple more slides on concepts. Oh, sorry, I forgot to show this little guy here. And then golden signals. Golden signals you may be familiar with, you may not be. It's not a Sumo Logic thing. It's actually a Google thing. Google's SREs, I guess 4 or 5 years ago, defined 4 key metrics to monitor, and they called these the 4 golden signals. The 4 golden signals, as they define them, are latency, traffic, errors, and saturation. The golden signals of those are important to understand the flow of causation in the root cause analysis. Roughly, when a system is under load, it can lead to either bottleneck, database storage issues, or availability. The bottleneck can eventually cause errors in the connected services. Likewise, lack of availability can increase latency in connected services. Errors and latency can lead to a drop in throughput in connected services. And very shortly, as I've alluded to, we're going to walk through a demo of the Root Cause Explorer, which is going to embody these 6 concepts to accelerate troubleshooting. And finally, didn't want to show you that. Not that I was hiding it, but wanted to just show data sources because this is a common question. In this section, we see how Root Cause Explorer applies those 6 troubleshooting concepts. And then Root Cause Explorer is going to use the following time series or metrics data, and as illustrated up here. For the 14, actually it's 10 AWS resource types, we use AWS CloudWatch metrics. From the Sumo installed collector, we gather those metrics for computing resources running on AWS, Azure, or GCP. Kubernetes metrics via the Sumo Kubernetes solution might be data that is used by Root Cause Explorer, as well as trace metrics via the Sumo tracing solution. To build connections between services and infrastructure, we leverage AWS inventory data, which helps gather AWS tags associated with the resource and also parent-child relationships, such as auto-scaling group or ELB target group membership. AWS X-Ray for service-to-service connections for service instruments, AWS X-Ray distributed tracing. Kubernetes hierarchies via Kubernetes dimensions. And then we also leverage service-to-service connections via Sumo Logic tracing service map. So let's go ahead now. Certainly if there's questions, go ahead and post them, but I think we're probably eager to see the magic that I've been describing. So here's Root Cause Explorer. Of course, an image of it. We're going to look at it in app. And originally I had planned to go through this slide and kind of look at it, but I think I'm just going to dive in app and just start walking through it a little bit. Let me see. Yeah, I think I will. Actually, let's go through a little. Let's do one screenshot here and then we'll get an app. So this is what Root Cause Explorer will look like once it's fully running. And we're going to go through each one of these options and features, the advanced options. There's a lot going on here. But what it's starting to do here is the anomaly detection. So we're starting to see here 4 different events that have occurred, the anomalies that are taking place. So we're going to look at those, of course. And we're going to start to look at drift, which is going to be an important component in our events of interest. So we'll talk about that in a moment. We see our timeline of spikes. You know what? Let me just go in app. Let's just do this in app. And you will be joining me in apps shortly. So I'm going to jump ahead in here. I'll have you guys do an exercise in probably about 10 minutes where we'll go through this together so you'll get that hands-on experience. So hopefully you've seen Sumo Logic itself before. If you haven't, this is the home screen, so welcome. But for today, we're going to be going to root cause. So for today, we're going to be utilizing the root cause explorer located either here or by going to new root cause. Either way, it brings us to the same place. And the place it's bringing us is to this root cause explorer. So as the image I just showed previously and now seeing in-app, there's a lot going on here, but let's start to kind of demystify it, if you will. Let's start with the center of the screen. Let's just get right into it. What we're seeing here are events of interest. So over the last 3 hours, and we can customize our time period, we're seeing events of interest, things that the system has detected as anomalies or unusual behavior, not necessarily bad behavior, but unusual, and letting us know about this, letting us be aware of these. And so what we see here, once again, this is quite cumbersome. We're going to start to clean it up in a second. But we see on the x-axis, we see time. So in this case, the last 3 hours, the x-axis representing time. The y-axis is going to represent drift. What drift is in Sumo world is a deviation from the norm, from the standard. So these are all showing that there are variations from what's considered normal, kind of using air quotes for normal here, but essentially what is normal. And then we see, there's so much going on, we see up here, using our legend here, what these different circles represent. So for example, red are errors, which we're probably going to want to look at those errors and see what's happening. We see latency, we see bottlenecks, we see success as well. And so this can start to help us identify what's going on. Let's go into some filtering. Let's jump into filtering here. The filtering gives you the ability to start to decide what sets of data you want to view in Root Cause Explorer. So as I mentioned, we're able to handle AWS data, Kubernetes, tracing, OpenTelemetry data, all that stuff can be pumped into Sumo Logic and be shown in Root Cause Explorer. But you have the ability to filter that. Maybe you don't want to see everything related to Kubernetes. And so you can turn off the Kubernetes events of interest and turn off the other ones as well. And we'll play with these filters more thoroughly throughout the day. Let's see, what else do we see in here? When we go over, which I was starting to show in the image earlier, but when we mouse over one of these bubbles, we get information specifically about it. So for example, this bubble right here, without looking at it, we see an error has occurred. When we mouse on it, we get information about that error. Specifically, it was a node error. Specifically related to our SE demo content, Kubernetes Docker operations. It's showing the drift. So it's showing this incident or this event was 698%, so quite deviant from the norm. And so it's giving us that insight, that information to start to understand what's going on. This is a time series. As I mentioned, time is on the x-axis. So as we go forward in time or back, we start to see those events that preceded or occurred after the particular item of interest, and we can start to do some, hence the name, root cause analysis into it. So let me go ahead and let me do an example here. I think this is a good spot for an example. All right, so for this example, let me see. Yeah, let's just go with it. So I'm going to actually clean up a lot of this to start to use the filters, but let me explain the kind of scenario that we're in here. So for this scenario, I want you to envision that you are an on-call user or employee, really, for a mobile banking application. So you're responsible for mobile banking applications. You receive an alert that there's a latency spike in the payments and account microservices, and that's quite concerning. As an on-call person for that banking app, spikes are concerning, especially latency ones. And so what I want to show now is how Root Cause Explorer can be used to locate these, actually first, verify that there are latency spikes, locate those latency spikes, and then try to figure out what has caused those latency spikes. And so what I want to kind of prove to you is I can do that all through one screen without doing too much on the keyboard as well, not too much typing. So let's go ahead and start to set up the scenario utilizing the filters. The first way I'm going to go ahead and start to utilize these is I'm going to go ahead and hide the AWS information and the Kubernetes information. Because I want to start, let me just make sure my data is here. Yep, cool, it's right there. What I want to start with is my scenario of service latency for the entity of payment and to the entity of count are being viewed right here. So what I see here are those latencies represented by the purple, representing my telemetry data that I've ingested. So these latencies didn't just happen magically. Well, maybe they did, but something had to occur for latency to happen. So that's what we want to see and start to look into the preceding events. So we see right here another service load related to the service payment. Okay, so we see the payment and account services. Great. And actually, let me go ahead and specify those in here. Since we really just want to look at those, we can filter and just look specifically at those two items. Now what I'm going to do is enable the AWS and the Kubernetes data. So for the AWS, I'm going to specifically just enable RDS data. We have a lot of different sets of data. That's why I should, one of the advantages of the filters is we can parse down our data to just that we need. And so that's what I'm doing here is I just, for this use case, I just need RDS. And then Kubernetes we can just enable. Oop. And then our mobile banking app. Okay, so what we've done here with the filter is just narrow down the criteria to our specific use case. So we see our latency as described earlier. And on the right-hand side of the screen, what we see are what we call top contributing entities. What we see here is a linear view of what has happened grouped by type of event. So if we look at these, we see the error related to account service and payment service. We see the latency that occurred just about the same time. And then we even see some load that occurred, which is probably going to be relevant. And so we're starting to see these entities brought together. So as we're starting to see, there was probably some load that happened here that may have caused the latency and the error, but we want to go a little bit deeper and once again, prove that to you, verify that that's the true scenario here. So I'm going to go ahead and turn off that AWS, turn on that Kubernetes again. And so at the application services, we see the load of the service load here that I just alluded to. Now we're going to go ahead and enable that Kubernetes layer for the same time frame. And what we see now is the increase in requests led to the increase in the memory usage of those deployments. Here, I see an error, and I see it's a deployment error, and I see it's a mobile banking related to my mobile banking app, but particularly the metric of deployment terminated pods. I should also see another error here for terminated pods. So what has happened so far, or what I'm viewing through this information is there was load, there was latency. There are now pods that within Kubernetes have been terminated. What caused it? They didn't just terminate on their own. And so now we're going to use Root Cause Explorer to keep digging. If we go into the AWS layer now, what we see here is the underlying RDS database. So where is that guy here? There it is. So what we see here is RDS load. Specifically, we also see the metrics of read IOPS that there's a lot of drift associated, meaning there's a lot of deviation there. And so when we go in there, we see that RDS, we see the services are taking, it has a load on the read IOPS. So what happened with this RDS overload subsequently? We see that there was the read IOPS load on this RDS instance that converted to a read latency on the RDS. So let's see that read latency. There it is, this read latency right here. And so the RDS could not handle the increased load. Therefore, the latency of the queries to the RDS spiked up. And so this could explain the increase in latency in microservices, but let's dig even a little bit deeper. What happened at the Kubernetes layer? As we saw previously, the deployments had a large memory pressure, and we see a graph of that over here for the showing our metrics and showing our pods here. And so we see that they were increased by due to memory pressure. The RDS was overloaded, the requests were being stalled at the microservices, and this led to an increase in memory pressure, which led to the pods of the Kubernetes deployment getting killed. If we go back and look at the same exact time range now with just the tracing application service, we see it's in that same time range. And once again, that time component is really important to recognize that all this stuff was occurring around the same time. Payments and account microservices, which were dependent on the Kubernetes deployments, had a huge spike in them because the Kubernetes deployments were under provisioned, because of the pods being terminated. The pods got terminated because of huge memory pressure, which is because the underlying RDS instance at the AWS layer was not able to perform at the spiked load level. Root Cause Explorer gives the visibility across these different layers of the application and enables you to correlate events across those layers in a single pane of glass. So that's an example of Root Cause Explorer. But what I want to do now is I really want to dive in here and have us do this together, go through a scenario that's might show or illustrate a little bit better. So I want us all to jump into the system right now. And let me go ahead and post the credentials right here. And let me go ahead and put those in the chat. And so what I'd like you to do is log in to Sumo Logic using these credentials. The website, hopefully you're familiar with, and if you're not, that's fine. But the website is service.sumologic.com. The account you're going to use, the credentials you're going to utilize for today are going to be training plus analyst number, and you are going to pick a 3-digit number. Maybe you want to be training analyst 123. Maybe you want to be training analyst 456 931. Pick a 3-digit number. We have a small group, so we shouldn't have really overlapping, and if we do, that's fine. And then for that password, it's going to be May Logic exclamation point, capital M-A-Y, capital L 0. So that's a 0 in that password. GIC exclamation point. So go ahead and log in. If you need assistance logging in, there's a couple people on the panelists that can help. So John, we have a bunch of them. Yeah, as John's pointing out, that's a 0 in that password. So capital M-A-Y, capital L 0 GIC exclamation point. So go ahead and log in, give you all a few moments here. These credentials, if you haven't used training credentials with us before, these credentials are, you can use them after today. You can use them really for the rest of the month. Keep in mind, though, it is a shared training environment, so we don't want you to put anything proprietary in there, anything, any security names you have, keep those out of there. So, but a great environment to mess around with. All right, so I should, once you're in, actually, if you could just go ahead and type in the chat, just to let me know that some of you are logged in. And if you're not, I hope you're reaching out to one of our helpers. And so give everybody a few more moments here. Once again, service.sumologic.com, training plus analyst, number, 245 378, but anything in between or any 3-digit number. And then once again, that password, capital M-A-Y, capital L 0 GIC exclamation point. If you're getting an error about account is locked, I would just try a different 3-digit number. It's possible somebody else got in and yeah, something like that. And you also should or may be able to copy the password from the chat. So, all right, I'm going to go ahead and continue on. If, like I said, please, if you have issues, questions, what have you, in the chat. All right, so now we should all be logged in, hopefully. And so let me introduce you to the scenario we're going to go through first. And that scenario is you are now, or at least for today, you are employees of Travelogic. You know Sumo Logic. We explained it earlier, but you might not be familiar with Travelogic. It's our sister company, a fictitious one, that handles a travel agency needs. So it allows users to go in and book website, book airfare, book hotels, travel plans, all that kind of stuff. And so that's what we are in the business of doing. Now, as a Travelogic employee, you've been hired specifically for your DevOps skills. And so it's important that you are going to support our mission critical app, which runs on AWS. It's going to focus on using these 3 things. So these are kind of your focus area for your job: ELBs, host EC2s, and DynamoDBs. And so what we want to do here is we hear that end users are experiencing an outage in the application, that they're getting 500 errors, which is a bad thing, is an error message. You can leave it kind of vague there. In the US East 1 area in the last 24 hours. So in the last 24 hours, users that are coming through or using the US East 1 instance that you may own, they're getting these errors. So as a DevOps specialist, your challenge is to troubleshoot and identify the root cause. So how are you going to do it? There could be hundreds, thousands of logs or different systems. So how do you go ahead and do this? Well, let's figure it out together. So what I want to do here, and I'm going to do this on my screen, and I'd encourage you to follow along and ask for help as needed. But what we're going to do here is we're going to go into root cause. So when you logged in, you should be brought to this screen. Your screen might have this black bar on the far left, and we're not going to use that today. So you can click on the arrow to get rid of it and hide it and free up some space. But for today, we're going to go into root cause. So either on this homepage, clicking on root cause, or going to new to root cause, same difference. Regardless, you should get to a screen that looks pretty similar to this, more than similar to this, should be probably identical to this. So I'm just going to wait a second, make sure everyone's able to get there. As mentioned, go ahead and yell if you need help. But now let's go through this scenario of what we want to try to utilize Sumo Logic for. So I'm going to go ahead and I'm going to start to use my filters here. Because with my filtering, remember, I just want to look at least in this step, in this use case actually, I'm just going to look at AWS data. So what I'm going to do is I'm going to turn off the application service. I'm going to turn off the Kubernetes just because I'm not going to be utilizing that for right now. And then I'm going to, let's see, I'm going to do anything else from here. Yeah, I am going to do something else here. What I'm going to do here is a couple things. Good call in the last 24 hours. So I'm going to set my time to last 24 hours because as Aresh just pointed out, we want to look at the last 24 hours. But we knew more than that. We also knew, or I told you, but we knew that we want to look at US East 1 over the last 24 hours. So what we're going to do in Root Cause Explorer is we're going to go to the region and select US East 1. I'm also going to, I was going to say cheat. It's not cheating. It's actually using the account ID in the proper format. I'm going to go ahead and select prod for production. So in this case, I'm saying, let's just look at production US East 1 data. And so when you do that for the last 24 hours, your screen should look pretty similar to this. Once again, yeah, it should look pretty similar. Now, the portion of time that I want to focus in, this I'm focusing in a little bit just due to the lab exercise. But what I want to do here is I want to focus in on this portion right here that occurred at about 6 a.m. this morning. 6 a.m. Pacific time, excuse me, that's quite an important distinction. And with the Root Cause Explorer, what I can do is I can actually zoom in on a set of time. So for example, here, I just want to focus on these 3 dots here that occurred at about 6 a.m. Pacific time. To do so, to zoom in on those, what I can do is click my mouse on the event of interest chart, just click on it, hold the mouse down, and drag down to specify a time period. So what I'm doing now is I'm now specifying really about 5:30 to 7 o'clock this morning. Really just zooming in on this portion. And this is the portion I want to focus on for today's discussion of trying to figure out what's gone wrong. So we now see our responsibility, our EC2 stuff. And so let's go ahead and look at this right now. The red representing the error. If we click on it, what we see is this is an error related to ELB, related to prod US East 1, as the filter should be doing, specifically the metric of HTTP code ELP 5XX. We see the drift. So what the system with the drift is letting us know is this is an abnormality or not. Yeah, abnormality. And then we even see a little metrics graph right here showing us, hey, things have been hovering, pretty low, pretty low, pretty low. And then a little while ago, there was a big spike for 5XXs. Now, we don't know what caused these 500 error counts yet, but we see them in the system. More importantly, the Root Cause Explorer sees them. Now, what we can do is just go back in time. So prior to this 500 event occurring, something had to happen for the 500s to occur. It didn't just magically happen. And so very simply, we can just click further back in our timeline. And what we see here is a host bottleneck. So there's a bottleneck issue related to the metric of CPU load average. So what we're kind of gathering from here is there was a load spike, and then there were 500 errors. But let's go back a little bit further, because while it's great to see that not great, it's helpful to see that there was a bottleneck. Once again, we need to figure out what caused that bottleneck. It didn't just magically happen. And so if we just click on this preceding or first EOI or event of interest, what we see is this error is related specifically to DynamoDB bottleneck, specifically to the read throttle events here. And so this is showing us that there appears to be an issue with read throttle events in DynamoDB causing a bottleneck, which has led to a CPU load average, a load increase, which has resulted in an increase here of the metric for the 5XX or the 500 error. Now, what we can do here is we can also go into infrastructure, and I haven't shown this yet. The infrastructure option is going to allow us to drill into some tables, some Explorer views that give us more information about the processes that are running within AWS. So what I can do here is I can go to Open in Entity Dashboard. And when I do, I get brought into a new view, or new to us today. And what this is showing me is for my DynamoDB, it's showing me a visual dashboard representation. We call this Explorer, of different things going on in this system. What I want to do, though, is I want to look specifically at the dashboard for events, because I want to see what events have occurred. Going to our story, or relaying our story, we see the 500 errors, we see the bottleneck, we see the bottleneck related to DynamoDB, the read throttle events, but what event caused that spike or increase in read throttle events? So we still don't know really the root cause yet. We know things that have taken place, but we're still looking for that root cause. So what we're going to do here is we're going to go into the dashboards and select events. And what I'm going to do here is I'm going to just play with my, I'm going to modify my time filter just to match that time series that I was just looking at. So I'm going to do about 5 a.m. to 7 a.m. today. And now what we start to see is an error related to provision throughput of write capacity units failed. So what appears to be the problem here is that there was an issue updating this table. The table could not be updated properly, or failed updating. As a result, since the table could not be updated properly or failed, the DynamoDB caused a bottleneck for read throttle events. Then the bottleneck occurred. Those load averages of 5 minutes are starting to spike or peak. And then finally, we see that ELB error occur. And so we were now able to utilize Root Cause Explorer to go ahead and start to see what was occurring and why it happened. And so the actual root cause was due to that increase in read throttle events, which was due to that table being improperly provisioned or updated. All right, great. So let's see, any questions so far? I know you're keeping John a little bit busy with some questions. So a few more things to wrap up. I do want to show one other way to get to, or one other, I guess we'll call it a feature of Root Cause Explorer. Now I showed this Explore environment earlier, but what I want to show in here is what we call the entity events of interest. What this is going to bring you to is almost a mini Root Cause Explorer. And so what we can do, and the focus, of course, is not on the Explore tab, but I just want to show this as an alternative way to get here. Well, what you can do is look at your different environments and utilizing the different dashboards, specifically the events of interest, we can start to see specifically here for DynamoDB what has occurred. Now, once again, this is not going to show us the other events that occurred related to these events, because these are not specific to the view we're looking at over here. In this case, we're just looking at the DynamoDB. All right. All right, so we went through a lot today, but let's go ahead and start to kind of wrap things up. So we talked about how RCE embodies those 6 concepts, the spikes being the first symptom of the incident, those earlier spikes being probably related to probable cause, the context and correlation of spikes really allowing us or helping us decide on a time range, which is really going to be important to focus in on a period of time rather than just looking at just a giant set of data across months and months of data. We want to really zoom in. The connection between the resources and the services, which are going to help to trace that root cause. The associated log exploration, that's going to help identify that real root cause. And then finally, those golden signals that are going to be important for root cause to utilize. The latency, the traffic, the errors, and saturation all get tied together to really make Root Cause Explorer function. Once again, the recap on the RCE steps, finding that time range, mentioned a few times, but as you can see, it's critical enough that it bears repeating. Seeing the connection, so utilizing the both the filter to specify on the connection, in this case US East 1, but also seeing which connection is being utilized. The different context filters helping to isolate the root cause, and then finally viewing the time series as you can do so. So certainly going to open it up to questions in a moment. I did want to remind you of our training that is available. So certainly today is an example of some of the training that we offer, but we also offer certifications and more workshops, and invite you to those. So I'm going to go ahead and paste that link in. So if you're interested in learning more about Sumo Logic, strongly encourage you to attend some of those classes. And now I'm going to open up to questions and answers. I guess you get the questions, I'll have the answers, but are there any? And you are on mute, so as a reminder, use the Q&A or the chat. Recording of this session will be available. Yes, it will be. I'll need to trim it up, but it should be available. I'll probably say later today, maybe tomorrow morning. But we'll go ahead and post it as well. All right, well, if there's no other questions, I certainly don't want to hold you here. So thank you for attending. Hopefully you found it helpful. Please, jump into Root Cause Explorer and start playing or using it, not playing with it. But I think you'll find it quite helpful. And so I'll stay on the line for another moment or two if there are any last minute questions, but feel free to disconnect. And once again, thank you for joining today. Sumo does support Azure. That question just came up. Yes. Oh, good, John. John's giving a little more detail on that. All right, looks like there's no more questions. So I'm going to discontinue the Zoom for today. And once again, like I said, thank you for joining. Thank you for interacting with us, and hope to see you at another training soon. Take care, everybody.